Fire is operated from a 240 volts AC main supply and it's rated at 1.5 kilowatts. When operating at a rated power, calculate the current used by the fire. We are going to do these three. Let's start with the first one. They're asking us to calculate the current used by the fire. From our equations of power, P is going to be I times V. This is Roman 1. Current times voltage. What is our current? They are asking us to look for the current. What is power? It is rated at do we have the power? Current used by the fire is what we want. The electric fire operated from that AC mains is rated at 1.5 kilowatts. So meaning that our power is 1.5 kilowatts. So it's going to be 1.5 kilowatts is going to give us current, which you are looking for. Multiply that by the voltage, and here the voltage is 240 times 240. So meaning that our current is going to be equal to 1.5 kilowatts, which is going to be, if you multiply this, convert this to watts, it means you're going to multiply this by 1000. It's going to become 1500 watts. Divide that by 240 volts, and it means that our current is simply going to be 6.25 amperes. That's the current. We go to Roman 2. The energy given out by the fire in 10 hours. Now we know that power is the rate at which work is done. And we know that when work is done, that is energy, meaning that power is going to be the energy over time. So it means that to get this energy, the energy given out by the fire in 10 hours, it means that energy is going to be equal to the power times time. Power times time. This is Roman 2. What is our power? Our power is 1.5 kilowatts, so it's 1500 watts. Multiply that by the time. The time is 10 hours. So it is 10 hours, but we are supposed to convert those hours into seconds. So it's 10 hours times the 3600 seconds that are contained per hour. So it's 10 times 3600. So it's 1500 times 10 times 3600 is going to give us 5.4 times 10 to the power 7 joules. And this is our energy. So let's look at Roman 3. They're asking us to find the cost of running the fire in 10 hours. If the cost per kilowatt hour is 300 Uganda shillings. So now, how many kilowatt hours are generated within 10 hours? So we know that this electric fire is rated at 1.5 kilowatts. So if it is rated at 1.5 kilowatts, this is Roman 3, the rating is 1.5 kilowatts. So meaning therefore the kilowatt hours in 10 hours is going to be the rating, which is 1.5 kilowatts times the 10 hours. So this is going to give us 15 kilowatt hours. But then the cost of 1 kilowatt hour is 300 shillings. So if the cost of 1 kilowatt hour is going to cost 300 Uganda shillings, so it means that 15 kilowatt hours will be 15 times that. It will be 15 times 300, and you end up with the answer as 4,500 Uganda shillings. And that will be the cost for running that fire in 10 hours. This brings us to the end of this video. Thanks for watching. Somebody out there would like to watch this tutorial. Please don't forget to like and share. For more videos, simply subscribe to this channel. For Kisembo Academy, this is Arnold Rangakuramya. Catch you in the next video.